1.3, right triangle trigonometry. So we're going to define our trig functions in terms of sides in the right triangle. So let's have a right triangle ABC and acute angle theta. So we've learned in the past in geometry or high school algebra the SOHCAHTOA, which means that sine of an angle theta, acute, is equal to opposite. So we have S stands for sine, C for cosine, T for tangent, O stands for opposite, A for adjacent, and H for hypotenuse. So the sine is opposite side over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So example, we have a right triangle with sides 3, 4, 5. Find the values of the 6 trig functions. So sine of theta, and here is theta, it's going to be opposite 4 over 5. Cosine is adjacent, so 3 over 5. Tangent is opposite over adjacent. So there are 3 other trig functions, so let's recall them. We have cosecant of theta, which is 1 over sine, the reciprocal of sine. So in our case, with the reciprocal of sine, so it'll be 5/4. Then we have secant of theta, which is 1 over cosine. The reciprocal of cosine in this case is 5/3. And finally, cotangent is the reciprocal of the tangent. So in this case will be 3/4. Another example. Find sine 45, cosine 45 degrees, and tangent of 45 degrees. We're going to use a special right triangle. This one is isosceles. Right triangle with sides, deliberately, we're picking them, the legs to be 1, 1, and then the hypotenuse will be √2. If we do Pythagorean theorem, 1 squared plus 1 squared is 2. So C, the hypotenuse, is square root of 2. So sine of 45 is opposite 1 over hypotenuse, and we rationalize this by multiplying by √2. So that is √2 over 2. Cosine of 45 is adjacent over hypotenuse. So the same thing if we rationalize it, √2 over 2. Tangent of 45 is opposite over adjacent, so it's 1.